Hello everyone there, Mr. Havel here. We're going to go over 7.3, which is partial fractions. Okay? So partial fractions are nice because we want to start with one simplified fraction like this and break it down into its individual parts so we can kind of mess with those individual parts instead of just having that big simplified fraction. Cool? So one way we could do this first one is instead of doing 7/12, we could break it apart to like 3/12 and 4/12. Cool. So that does still add up to 7/12 there. And then when I simplify that, we end up with 1/4 plus 1/3. Okay, so we're able to break 7/12 down into these two fractions here, which is 1/3 plus 1/4. Okay. And you can read here the partial fraction decomposition, so breaking it down, the process of starting with one simplified fraction and splitting it into two whose sum is the same as our original one, right? So we're not changing anything, we're just changing maybe the appearance of it. Cool. So here's a sample of it right here. You can kind of read over your notes, but that's our idea, what we're hoping to do, okay? So certain processes in calculus can only be done with fractions that have been decomposed, right? So we want to see those individual parts so we can, in calculus, mess around with them, okay? So here, this is a very nice table. Different forms, okay? So different forms of these guys. And if you notice, this is the form of the denominator, right here on the left-hand side column. This will be a form of the rational function, okay? And then our goal is to get over here to like the pinkish red one where we form the partial fraction. Okay, so this is kind of what I would consider the setup, and then this is kind of the answer type of thing. Okay, so you can kind of look through each of those. It's really nice. We got linear factors that are repeated, a bunch of unique linear factors. Again here, linear, one is repeated, one is not. And then down here we have, right here we have a quadratic factor, changes up. And you notice the difference with the top, okay? So it says here, this guy that we just talked about cannot be factored further. Okay, so you're gonna see if you can factor these, but most of the time when you have a fraction like this, it's already simplified, but always check to make sure that you can maybe factor it a little bit more. So here, our last one, if you notice on this, I'm going to scroll down because there's an important part right here. Cool. So the important part, it says the numerator, okay, when we break it down, so we're talking about this column right now, that third column, the numerator will always be 1 degree less than the factor of the denominator, okay? So we're not going to try to, if you see a squared, like this example right here at the top, we're not going to FOIL it out or anything like that. We want it in the factored form, okay? And so it'll be 1 less than the factor, okay? And so the reason, if you see above here, this guy, we don't necessarily look at this for our degree. We're going to look at what is the degree inside the factor. So here it's got a degree of 1, right? So if it's got a degree of 1, you notice in my numerator it's just a constant. So A, B, and C, or A, B, C, D, all of the letters that we'll put on top are all just constants, okay? Whereas here, if you notice, this factor has a squared in it. So 1 less than squared would just be an x, okay? And so that's the big difference, is so if it's squared, the numerator will have a power of 1. If it's just to the first power, then the numerator is just a constant, okay? So what you're gonna do for this example here, look at one thing at a time, right? So if I look at this factor, it's just a constant, or sorry, it's just x to the power of 1. Right? So 1 less than that would just be a constant. So we do x over a. Now, it doesn't matter. We're going to be solving for A, B, C, all of those. So it doesn't really matter what the letter is up there, but, you know, we I guess kind of default start with A and then keep going, B, C, D, E, F, all that kind of stuff, okay? Now, this next one, if you look, there's a couple things going on here. Number one, the degree is squared, and then if you look, the factor is also repeated. It's also squared, okay? And so the way that we deal with repeated ones is kind of like up here. We do the factor by itself, and then again we do the same thing, the factor, but that factor squared, okay? So for us, since we have a squared inside of the factor, one less than that in the numerator is going to be bx plus c. Okay, so you always do one less, and then you keep going down until you get to the constant c, right? So, and then we do the factor one time, x squared minus bx plus c. Right? Now we do the same thing. Since the factor itself is squared, we repeat it, and so now keep going. So dx plus e all over the factor itself squared. Cool. So right now it looks a little bit wonky, but once you get a few of these under your belt, they go pretty quick. Okay. So these first four examples here, the highlight, the bolded one, please circle it, everything like that, so you don't get angry when you solve it out. So when it's asking for the form, all it wants you to do is that third column, okay? All it wants you to do is break apart the fraction. So it doesn't want you to solve it yet, okay? We're not gonna solve for A, B, and C. So we're just gonna break it apart into the form itself. So this first one's nice. If you notice, we have two different factors, each one with a power of 1. So we're going to say equals A over the first factor. And we did the constant there because the power is 1. And then plus, you'll notice all these are going to be plus B over x plus 3. And that's it. That's the form of the partial fraction decomposition. Okay. We'll jump over to 2. Same thing. So that's just a one factor with a degree of 1. So we have a constant. So x plus 1. Now this next one here, this one has a degree of 1 inside. So we'll just use a constant, but the factor is repeated. So what we do is we do b over the factor itself, and then the next one, c over the factor squared. Cool. Now 3, if you notice, a lot of these are the same to start out with. So we have a constant over x minus 1 plus, now the factor is not squared, so I don't need to repeat it, but inside the degree is squared there, so I need to do one less, so that's plus bx plus c over x squared plus 5x plus 1. Cool. Cool. Moving on. So our last one here, we have the degree squared and the factor squared. So that tells me I'm going to do ax plus b since since the degree is 2. So I do one less and just do the factor by itself. Now I do another one, cx plus d, with the factor itself squared, right? So x squared plus 7. And so that would be the final form of that partial fraction. Cool. So the steps to do this, number 1 is what we just did, right? We write the form of the decomposition. And then we're going to multiply the entire thing, both sides of the equation, by the common denominator. Okay, and so what you'll notice is the common denominator is always going to be your denominator on the left-hand side. Okay, so on these, this is the common denominator. common denominator, common denominator, common denominator. So you don't have to put a whole lot of thought into that. Okay, so what I do is I multiply everyone by common denominator. Cool. And then here, we're going to solve for those constants. Okay, so we'll solve for the A, the B, the C, all that kind of stuff using a combination of strategies. So our idea is if we have just a straight up factor like x minus 3, we're going to let the variable equal the roots, right? So equal the solutions and solve. Okay, that one's kind of the easiest one to see. And then here set like terms together, right? So if I have two sides of an equation, all of the x squareds on one side of the equation should match all of the x squareds on the other side of the equation. Okay, so let's try this for number 5. So the first thing we're going to do is set up our form, right? So both of these are factors with a degree of 1. So I just do a over x plus 4 plus b over x minus 3. Okay. Then you multiply the entire thing. This is what I like to do. I multiply the entire thing by our common denominator, which happens to be this guy, right? So we multiply x plus 4 and x minus 3. So you'll see the process over and over, but these will always cancel out with these guys, right? So on the left, I have 5x minus 1, and that's it. Now on the right-hand side, one of the factors is going to cancel with one of the common denominators. So in this case, the x plus 4 and the x plus 4 will cancel and leave me with a times the other factor, x minus 3. Plus, same thing for b, the x minus 3's cancel and leaves me with x plus 4. So that's kind of step number 2/3. Set those guys equal. Okay, and then step number 4, we're going to go through and figure out how do I solve for these a's and b's. I want to get those guys equal. So I'll write out all the steps here, but make it a little bit shorter as we go. So if I say if x is equal to 3, the solution to this guy, right? If x is equal to 3, then I plug everything in. So 5 times 3 minus 1 is equal to a times 3 minus 3 plus b 3 plus 4. Cool. So this on the left-hand side, we end up with what? 14. Now the nice thing here, this is a times 0. So it gets rid of one of my unknowns that I'm trying to find. So plus b times 7. Cool. So the a goes away, and so I'm just left with b times 7. So divide each side by 7. So b is equal to 2. Cool. Now you're going to repeat it. So I know what b is. Now I need to figure out a. So, well, in order to get rid of b now, I can look at solving this factor, right? So if I say if x is equal to negative 4, I go through the same process. 5 times negative 4 minus 1 equals a times negative 4 minus 3 plus b times negative 4 plus 4. Cool. So this becomes what? Negative 21 is equal to a times negative 7 plus b times 0. Woohoo! The b goes away, and I can solve for a to equal 3. Cool. So we are like 99% of the way done. Now our final answer is to actually write out the fraction with our a and b involved, right? And so I'm going to write out this fraction that we had up here, but with the a and b. So my final answer is going to be a, which in this case is 3, over x plus 4, plus b, which is 2, over x minus 3. Cool. So that right there, that is the decomposition of that fraction. So that would be my answer right there. Okay. So a couple highlights as you guys are smarty pants. When we start doing this, we don't necessarily need to write out all of these steps and show that b goes away. Again, you guys are smarty pants. When it gets a little bit more challenging, maybe we'll write some more stuff out. But again, I have confidence in you guys. Cool. So this first guy here, factor, it's still a factor even though it's just one term. It's degree of 1, so we have a over x. Now here, the degree is 1, but the factor is repeated. So I do b over x minus 1 plus c over x minus 1 squared. Cool. So that is the form. Now I multiply everybody by the common denominator, and this is your common denominator. So I'm going to multiply by x minus 1 squared. As always, the left side gets rid of everyone, so I'm just left with the numerator. Now the a gets rid of the x portion of it, so then I'm just left with a times x minus 1 squared. B gets rid of one of the two factors of x minus 1, so I'm left with plus b. The x is still there, and one of the two x minus 1s is there. And now c gets rid of both of those x minus 1 squared, so I'm left with cx. So it gets a little bit trickier, but if you notice, so now I need to get rid of 2 out of the 3 letters in order to solve for that third one, right? So if you look at a and b, they both have in common the x minus 1s, right? So if I say if x is equal to 1, and we'll do a little shortcut here, x equals 1, that goes away, and that goes away because that 0 times bx is 0. So the nice thing, if I plug it in, I have 1 plus 2, which is 3. A goes away, b goes away, and all I'm left with is c times 1. All right, so right away, I know what c is. Again, that's because if I plug in a 1 here and I plug in a 1 here, both of those go away and leave me with just c. Now, very similar, if you notice other factors, is there another factor that is common between 2 of the 3 that we haven't solved for yet? And the answer is yes, right? This has an x and this has an x. So if I say if x is equal to 0, on the left-hand side I have 0 plus 2, so 2. Now here I have a, 0 minus 1, so negative 1 squared. Now this is 0 times that, so this goes away, and 0 times c, so that goes away. Right, so I'm left with this. So if I square negative 1, it's just 1, so a comes out to be 2. Now our last step is I need to figure out b. I've got a and c, but now I need to figure out b. Now, unfortunately, if you look around, there's nothing that a and c have in common that b doesn't have in common, right? So b is kind of the best of both worlds of a and c, so I need to figure out a different route, okay? I'll show you everything on this step, but again, then I want to show you kind of a shortcut to go a little bit faster. Cool. So now what we're going to do is we're going to compare all of the x squareds, the x's, and the constants, right? And so what I would do, I'll write it right over here on the side, but I'm going to have x plus 2 equals, now if I FOIL out that x minus 1, I end up with x squared minus 2x plus 1 plus bx x minus 1 plus cx. Cool. And now I'm going to distribute all these guys in. So I end up with x plus 2 is equal to ax squared minus 2ax plus 1 times a, so just a, the constant, plus bx squared minus bx plus cx. Okay. And so, again, this is way more writing than I really want you guys to do, but I want to show you kind of the process right here. So my last thing that I'm going to add is, if you notice on the right side we have an x squared, but on the left we don't, right? So what I could do is I could add in a 0x squared so that I can compare. Now I'm bringing all my x squareds together. So I've got ax squared plus bx squared. Cool. Let's change up the pen color here. So those are all my x squareds. Now my x's from Texas minus 2ax and then minus bx plus cx. And then my final one is my constants. So the 2, so the only constant I have here is a. Cool. So now what you want is you want all the purple guys to match each other, all the red ones to match, all the green ones to match. And if you notice here, the only green is a, and look, equals 2. Ta-da, we already found that. Cool. Okay, so now the only thing I need to do is find B. Well, B is in the reds and also in the purples. I would go for the purples just because there's less variables. That's it, right? So now I'm going to set all of the purples equal to each other. So we'll say, a lot of times I'll say the x squared value. That's what I'm looking at. So I do 0x squared is equal to ax squared plus bx squared. Cool. Well, they all have x squared, so we can cancel those out. So we have 0 is equal to a plus b. Now, I already know a, so I can plug in a. So 0 equals 2 plus b, and solve for b. Okay. So we couldn't do this step at the very beginning because we needed to know something else besides b in order to solve for b. Okay. So we had to do those first steps first. Okay, so that is all of the work to get all of our variables there. And so now I just plug in back into this equation up top here. Whoop, whoop, hey, come back. Okay, so I plug them all back in. So back into this equation here. So a is, just be careful, a is 2, so over x. B is equal to negative 2. You could do minus, or a lot of times I'll just do plus, and then negative 2 over x minus 1. And then plus c, which is 3 over x minus 1 squared. So that is your final solution there. Cool. Okay, so this next one, let's do this process a little quicker. Okay, so we'll do that process a little quicker so we don't have to solve everything out every single time. Okay, so let's cruise through this. You can slow it down and repeat it if you need, but we got a few more problems, so I'm going to go a little bit faster now. So this one's a constant, so x plus 3. Now this one's repeated, so I'm going to do, squared, so bx plus c over x squared plus x plus 2. Now multiply everything by the common denominator, which is going to be x plus 3, x squared plus x plus 2. Shabam. Okay, leaves me with 8x squared plus 12x minus 20. This one's a. The first factor cancels out, so I'm left with x squared plus x plus 2. Now this guy, plugging in an x value is really challenging most of the time, so we're going to kind of ignore the value of like if x is equal to something, so with that bigger trinomial. Cool. So a couple things that are easy to see. Notice how I put parentheses around this because it's bx plus c times that whole thing times the x plus 3. So the nice thing is if I do x is equal to negative 3, this goes to 0, and then I have 0 times that, so it gets rid of both two birds with one stone, the b and the c. Cool. So let's cruise through this super quick. So if I plug in negative 3 up to this first one, I get what? 8 times 9 plus 12 times negative 3 minus 20 is equal to a times, same thing, we've got negative 3 squared minus 3 plus 2. Okay, parentheses there. And plugging this into your calculator, you get 16 is equal to a times 8. Right? And so that's an easy one. A is equal to 2. Sweet. Okay, so that works out well for us there. Now we need to figure out the rest. We need to find the B and the C. So again, like I said, this part of it is really hard to figure out, almost usually impossible to figure out a value that makes it go away. So now we're just going to look at the constants, look at the individual parts of it. So if I look at, I would like to do the x squared. I don't know if this is going to work yet, but at least I can set it up. If I'm missing some information, then I can go back and solve it. So I'm going to go through and look at anything that would be an x squared. So this is kind of a shortcut of what we were just talking about before. I look on the left, the only x squared is the 8. Now here on the right side, I have a times x squared. Yes, I could distribute that a into all the other two, but all I'm looking for are the x squared values. So that'd be a. Okay. Now b, right? So if I did bx times x, that gives me x squared as well. So I get a plus b. Now if I look here, bx times 3, that's an x value, right? Cx, that's an x value. C times 3, that's a constant. So I don't care about any of those. So this is kind of a shortcut. So all these, I'll write it out. These are all your x squared values. Again, I don't need the x squared because they all match that, right? So they all have the x squared. So really what I have is 8 is equal to a plus b. And I already know what a is, right? So 8 is equal to 2 plus b. So therefore, b is equal to 6. Okay. So the last thing that I need to go through and figure out is my c value. Okay, so make it as easy as on yourself as possible. So one thing you notice, bx will never be a constant, right? Because the x is attached to it. So in my opinion, I would look for constants. So the constant on the left side is the negative 20. Now a, right, I can have a constant here because it's 2 times a, right? So this would be 2a. And then again, bx times anything would at least have an x attached to it because of that. So I'm not going to use that. So the only constant here would be the c times 3. So 3c. Now I know what a is, right? So a is equal to 2. So I have negative 20 is equal to 2 times 2 plus 3c. So if I move this over, that's what negative 24 is equal to 3c. So c is equal to negative 8. Cool. So now I have the a, b, and c. I can plug it back into my original form and get the partial fraction decomposition. So a is 2 over x plus 3 plus b, so 6x minus 8 over that whole factor x plus. Cool. And so that is my fraction there. Cool. Okay, definitely a lot of writing on here, but once you get the pattern, it's pretty quick, relatively quick if you once you understand this pattern. So this one's a little bit tricky. We have a degree of 2 and it's repeated. So I have ax plus b over x squared plus 1 and then plus cx plus d over x squared plus 1 squared. Multiply everybody by the common denominator, which is x squared plus 1 squared. Again, the left side always comes out to just be the numerator. Now the ax plus b gets rid of one of the two factors, so I'm still left with the other one. So just x squared plus 1, not squared. And then the last one is gets rid of both of those factors. So those guys are gone. Okay. So now looking through this, there's nothing, to be honest, that jumps out at me, right? So this one's hard because it is it's an x squared. So if I solve this guy out, it'll end up being an imaginary number, right? So we're not going to use an imaginary number on there. So look at common trends. So I look at the cubic one first, so x cubed. If I look at all the x cubes, on the left we have 2x cubed. On the right here, okay, that gives me an x cubed. if I look for any other x cubes, nothing else gives me an x cubed, right? So therefore, I get ax cubed. So a. Ta-da! Done with that one. Cool. Now, x squared, if you look here, do I have an x squared on the left-hand side? And the answer is no, so I could just put 0, because it's 0x squared. Okay, so 0x squared. Again, I'll write this just so we can see it. Now the ax, if I look at anyone over here, there's nothing that's going to give me an x squared. So ax times x squared is x cubed. Ax times 1 is just x. Well, this right here would give me an x squared, right? And if I look, that's the only thing that's going to give me an x squared. So therefore, we know that b has to be equal to 0. Okay. And now x on the left-hand side, here's our x, so it's 1x. So this right here would give me an x, right? So that gives me ax. Now I'm going to look here. Do either one of those give me an x? No, it gives me a bx squared and a b. And then so my only other x is that c. Well, I already know what a is. A is 2, right? So I have 1 is equal to 2 plus c, and then subtract it over. So c has to equal -1. And our last one is all of our constants. Cool. So I've got a 3 there. Now again, ax is never going to give me a constant because it's got an attached x. So if I look at the b's now, right, b times 1 gives me a constant, so 1b, and then this guy's a constant, which is d. Well, I know what b is 0, so if b is 0, then d has to equal 3. Now I come back to my original form. Yes, b is 0, so it kind of goes away, right? So for my form, I have 2x plus b, which is 0, so I don't need to write that. And then c is, again, I like to do plus here and then put the c value here. So -1x, d is 3 over x squared plus 1 quantity squared. Cool. Now, again, I've said this a few times with this guy. If you want to bring out that negative, so if you want it here, what you'd have to do is do a negative here, and then this would be x minus 3. Okay, so you'd have to do that whole factor if you wanted to bring the x outside. Or sorry, not the x, the negative outside. Cool, so I like just setting it up like that because it's very consistent. All right, a couple more problems here. We have this one. I'll cruise through this one. This is one in class that we're going to have you guys kind of do on your own because it's a repeat of the first one that we did. Okay, but all right, so cruising through this one super fast. This would be a over x minus 4 plus b over x plus 2 multiplied by the common denominator, x minus 4, x plus 2. We are left with x plus 14 is equal to a times the other factor, x plus 2, plus b, the other factor, x minus 4. If we say if x is equal to -2, gets rid of this, the a. So -2 plus 14 is equal to 12. So 12, that goes away, and then we have b, -2 minus 4 gives me -6. So b is equal to -2. Now, if x is equal to 4, to get rid of this b factor, we end up with 4 plus 14, which is 18, is equal to a. 4 plus 2 is 6. So a comes out to be 3. Okay. So our final fraction here would be 3 over x minus 4 plus -2 over x plus 2. Cool. Okay, let's check out this next one. Again, this is kind of a repeated one, and so in class we'll have you guys do this alone. So a over x plus, this is a repeated one, but degree of 1. So Good. Multiply by the common denominator, x plus 3 squared. We have x minus 18 is equal to a. The x goes away, but I have the x plus 3 squared plus b. Get rid of one of those x plus 3 factors. So I'm left with x and x plus 3. And then c gets rid of two of those factors and then left with a cx. Okay? So this one's a very common one where a and b have a common factor and then b and c have a common factor. So the common factor with a and b is x if that's equal to negative 3. A and b go away, so I'm left with negative 21 is equal to c of a, c of b, and then c becomes negative 3c. So c is equal to 7. If x is equal to 0, which b and c have in common, the b and c go away, so I'm left with negative 18 is equal to a times, if I plug 0 into here, 0 plus 3 is 3, 3 squared is 9, so a is equal to negative 2. Now the last one is, I don't have anything necessarily in common with a and c, so I'm going to do x squared. Okay, so again on the left side I don't have anything, so I'm going to put a 0. Now if I FOILed this out right here, okay, I wrote it twice, and then I distribute in the a, I get ax squared. Now bx times this x gives me another x squared, and that's the only x squareds I can get from the problem. Well, I already know what a is negative 2, so therefore b has to be 2. All right, so our final thing would be negative 2 over x, whoop, that looks wonky, plus 2 over x plus 3, plus c over x plus 3 squared. Ta-da! Okay, our last couple, not too crazy. Again, kind of repeat ones here. They just look ugly because they're so big, right? And so here, this has got to be ax plus b because the degree is 2, and since the factor is repeated, I've got to write it twice. So cx plus d over x squared plus 1 squared, common denominator. So x squared plus 1 squared. And on the left leaves me with the numerator. Get rid of one of the two factors here. Leave me with the other factor. Okay, very similar to a problem we did, I think like 3 problems ago. And then this last one gets rid of everything. Okay, so again, go through the process, x cubed. The only x cubes I have is 5x cubed. And then on the right-hand side, I have ax cubed. So a is equal to 5. If I do the b's, or sorry, holy cow, the squareds, I end up with negative 3x squared is equal to, no x squareds from a, but I would have bx squared. And that's only x squared. Okay, so b is equal to negative 3. Now our x, I'll change colors here. Our x, it would be 7x. Now a would have an x, so that would be ax. B would not have an x, but c would. And then d does not either. So if I solve this out, we've got 7 is equal to 5 plus c, so therefore c is equal to 2. And our final thing is our constant. Right, and so our constant on the left would be negative 3. Over here, ax would not give you anything. B times 1 would. So b, and then d would be the only other one. Cool. B is negative 3. So we have negative 3 equals negative 3 plus d. And so therefore d goes away. Cool. And so our final fraction here would be 5x minus 3 over x squared plus 1 plus c, which is 2x. D goes away because that was 0. X squared plus 1 squared. Awesome. All right, one last one. Sorry, this one's a longer lesson, but you can kind of zip through it if needed. All right, set up our form here. So a over x minus 2 plus, this is not repeated, but it is degree of 2. So I need the bx plus c. Get that common denominator. Minus 2 x squared plus 2x plus 4. Sweet. Left side, just the numerator. 17x plus 14. A gets rid of the x minus 2 factor, so it's left with this guy. And then the bx plus c. Leaves you with the other factor. Okay, so this one's a nice one. If x is equal to 2, it gets rid of both the b and the c. So this one's a little bit tricky. If you calculate it out, I'll let you guys do it in your calculator, but if you plug 2 into all the x's, then you end up with 60 is equal to 12a. So I just plugged the 2 into all of these guys. Okay, and so therefore a comes out to be 5. Now we kind of go through different ones. Again, this factor right there makes it almost impossible to plug in an x value, so we're just going to start picking out stuff. So we'll do x squared. So we have 3x squared. On the right hand side we've got ax squared, and then that would also give you something, so plus bx squared. Cool. So if I plug in, I know what a is, so we have 3 is equal to 5 plus b, so b is equal to negative 2. Now let's check out our linear factor, so just x. So 17x is equal to, that would give me an x, so 2ax. That's it. This would give me an x, negative 2bx. And then our last one here would give me an x as well, so that would be plus cx. Now we know 17, we know what a is, we know what b is, and then we're trying to find c. So if we solve this out, on the right hand side we have what, 10 plus 4, so 14, 17 minus 14, c is equal to 3. Our last one, woohoo! Good job, you guys stuck through this. So constant, on the left we have 14, here we have a times 4, so 4a. And I don't know why I'm still going on this one. We have a, b, and c. Cool. I was just getting too excited, I guess. So we have a, b, and c. So my a is 5 over x minus 2, plus b is negative 2x plus 3 over x squared plus 2x plus 4. Ta-da! Alrighty, tell a friend. I hope you enjoyed it, and we'll see you back for 7.4. Adios.